The weather and climate often cause concern and curiosity, but understanding the facts behind the phenomena can be a challenge. We're here to help. From the University of Illinois Urbana-Champaign and Illinois Public Media, welcome to Weather Realness, a weekly podcast about the skies above Illinois and the world.
I'm your host, Steve Nesbitt, professor at the Department of Climate, Meteorology, and Atmospheric Sciences at the University of Illinois Urbana-Champaign.
On a two-strike pitch. Hits a drive down the line. If it's fair, it's his moment.
A home run can make a baseball fly over 400 feet. Babe Ruth famously said to hit a home run, he swings as hard as he can right through the ball. But weather conditions can also play an important role in the game. So joining us to talk about how the weather can impact baseball is Alan Nathan, Professor Emeritus of Physics at the University of Illinois Urbana-Champaign. So during his career, he researched primarily nuclear physics, but in the past 3 decades, he's also delved into the physics of baseball, from baseball bat collision to the flight of the baseball itself. Did you have a moment or a eureka moment when you decided that weather actually does affect the game?
I think it's always been understood that weather affects the game, but I don't think anyone has thought about it in a quantitative way, like how much does it affect the game? And my eureka moment came when Major League Baseball started doing all this technology in the ballpark that allowed you to actually track the baseball. So rather than guess how far the ball went, you could actually measure it. And armed with information about what happened as the ball left the bat, as long as, in addition to where it ended up, you could start to do some serious studies of various things, including how weather might affect the distance.
So one of the things that you found is that there's a relationship between home runs and temperature. Can you describe what you found?
Sure. For some background, so if baseball were played in a vacuum, okay, it would be what I like to call a Physics 101 problem. Any freshman physics student could calculate how far it goes. It's just the only force acting on the ball is gravity. But baseball's not played in a vacuum. It's played in the air. And when the baseball flies through the air, it is colliding with air molecules. And every time it collides with an air molecule, it loses a little bit of its energy, very, very tiny little bit. But of course, there are a lot of air molecules. And so what I'm describing is the process of aerodynamic drag, which slows the ball down. And when the ball slows down, it doesn't travel as far. And that's the primary effect that that the air density has. Now, regarding temperature, when the temperature is higher, the air molecules are flying around faster. They're, in a sense, repelling each other, so the air density is less. Therefore, fewer collisions, less drag, the ball carries further. And then the opposite, of course, happens at low temperature. When the air density is higher, the ball doesn't travel as far. And one could be quite quantitative about that.
So quantitatively, let's say you have a certain change in temperature. Have you quantified how much, let's say, 10 degrees affects the rate of home runs?
Sure. So 10 degree. So let's suppose the temperature is higher by 10 degrees. For a typical ball on a well-hit fly ball, something that's initially traveling at maybe 100 miles an hour, about a 30-degree launch angle, that ball will travel close to 400 feet. If you raise the temperature 10 degrees, it'll travel somewhere between 3 and 4 feet further. I sort of got it more precisely as 3.3 feet, but anywhere between 3 and 4 feet is probably about right. And that'll change your probability of hitting a home run by about 10%. It'll be just averaged over all the major league ballparks. It'll be about a 10% increase in home runs when you do that.
And of course, other parts, hitting it in the ballpark, it might make it less likely to be fielded or change, whether the infielders have a chance at getting it if they jump and things like that too.
Absolutely. Yep. Yeah. It affects it in many ways.
So thinking about other weather conditions, of course, I think people obviously talk about, playing in Denver as a home run hitter's paradise. Right. Have you seen that effect, and does it follow sort of the predictions of density versus altitude?
Absolutely, yes. Denver is a mile high, a mile above sea level, and the air, for all other things equal, the air density in Denver is about 80%, maybe 82% of what it is at sea level, and that produces very noticeable effects. So that 400-foot home run, say, in New York, would be probably a 425-foot home run in Denver. It's a huge effect. In fact, it's much larger than any other weather-related effect that you typically see.
And for, many sports, a lot of athletes will complain about playing in Denver. I remember, I'm a fan of the Buffalo Bills, unfortunately, and when they had to play Denver, everybody was in oxygen and trying to get accustomed. But baseball, you're not really exerting yourself so much when you're hitting, so I guess there's less of a trade-off there.
Yeah, I think for batters, it probably has no physiological effects. For pitchers, it might be a different story. They're working a lot harder.
Right.
They're pitching, a half an inning every inning, and, they're throwing maybe 100 pitches, and if you're not used to being at altitude, that could have an effect.
Yeah, so the Colorado Rockies probably benefit from that, although we really haven't seen that much in the results, apparently.
They benefit from it because they're acclimated to it. But, it's a double whammy this for pitchers at Coors Field. Not only do fly balls carry further, pitch balls don't break as much for the same reason.
Yeah.
So it's doubly difficult for pitchers at Coors Field.
Yeah, maybe the knuckleball might be a little bit more effective there.
Actually, that's an interesting question. The knuckleball probably doesn't move as much, again, for the same reason. These aerodynamic effects all more or less scale with air density. However, it might be easier if you're a pitcher to control the knuckleball. So the net effect is a little harder for me to predict.
Yeah, that's interesting. Wind, obviously, playing in central Illinois, my son plays Little League, and, depending on how the field is oriented and the winds on those days, it certainly can favor that. Can you talk a little bit about how the wind impacts baseball?
Yeah. When I said that the altitude is the biggest effect, actually, I lied a little bit. I think actually wind is an even bigger effect because it's often unpredictable. It's, until recently, not so easy to measure where it matters. Nowadays, they can do that, and I can describe that if you like. For example, if you this typical fly ball that travels 400 feet, with a 5-mile-per-hour trailing wind, that ball will travel about another 15 to 20 feet further with a barely perceptible 5-mile-an-hour wind. So wind really matters a lot. And when trying to look at data from Major League Baseball to learn about the aerodynamic effects, the wind is hard to take into account because there are no measurements of it. So typically I only use data from covered stadiums like Tropicana Field in St. Petersburg, and stadiums that have a retractable roof for games when the roof is actually closed, because that will be more reliable without the unknown effect of the wind entering in.
So you mentioned that they're now measuring winds inside the stadium. Can you talk a little bit about that?
Sure. There is this company called Weather Applied Metrics. And this is sort of a two-part thing. What they do is they have sensors at various places in the ballpark that sort of just sampling the wind speed and direction. But more importantly, they have these elaborate computational fluid dynamics, or CFD models, where they take the wind as measured at some distance, either very high or further away from any obstacles. It's the obstacles, the ballpark, in the ballpark or buildings or whatever, that really can play havoc with our knowledge of the wind speed and direction. So they know the wind speed and direction at some point away from all the obstacles. They have their CFD model, which then tells them at each point in the stadium, 3 dimensions, what the wind speed and direction is. And they validate that with these sensors that they have in the ballpark at various spots. And so nowadays they're actually able to determine much better than we ever could the effect that wind has on any particular fly ball.
Yeah, and I think, we're starting to use more and more LiDARs, which can also do kind of a 3-dimensional view of the wind. It'd be interesting to look and compare with some of those models, which, I've been in stadiums. Sometimes the wind is blowing inside the stadium completely a different direction than it is outside because of the swirling.
And if you're in the stadium and you look at the flags around the stadium, and you often see the wind in different directions at different points in the stadium. So it's a 4-dimensional problem, 3 spatial dimensions and 1 time dimension. So it's varying in all 4 of those dimensions.
If you're just joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois Urbana-Champaign. I'm Steve Nesbitt, professor in the Department of Climate, Meteorology, and Atmospheric Sciences here at the U of I. Today we're talking about how weather affects baseball and how it's played with Alan Nathan, professor emeritus of physics at the University of Illinois Urbana-Champaign. So in 2022, for the first time, Major League Baseball decided to store game balls in humidors. You may have heard of this if you're a cigar aficionado, at all 30 stadiums. So can you describe what a humidor is and how it affects baseballs?
Sure. Well, so the humidor is an environment with a specified temperature and relative humidity. So, for example, in most of the major league stadiums, the baseballs are stored at 70 degrees Fahrenheit, 57% relative humidity. So, why is that important? Well, if the ball is stored, for example, in a much more humid environment, like you might find in Miami, for example, it absorbs water from the atmosphere. That makes the ball a little bit heavier, but more importantly, it makes it less bouncy. So there is a property of the baseball called technically the coefficient of restitution, which controls how much it bounces. You drop the ball and it bounces to a certain height. Compare that with a Super Ball, which bounces to a much higher height. So a Super Ball has a higher coefficient of restitution than a baseball. As a result of this, there is a great variation from one ballpark to another, as well as from one climate to another throughout the baseball season as the weather, the humidity is changing. There's a great variation in these two properties, the weight and the bounciness or coefficient of restitution of the baseball. So when the coefficient of restitution is high, the ball can be hit harder. When it's low, it's not hit as hard. So it definitely has an effect on how the game is played.
So can a pitcher feel this?
I have been told that when the ball is very dry, that the leather cover on the ball feels very slippery to the pitcher, making it harder to grip compared to when it's not as dry. I haven't experienced that myself. I've just been told that.
And do you know if the balls are continuously taken out of this humidor, or do they bring them out at the beginning of the game?
They bring them out at the beginning of the game, but you might wonder, well, if you're stored at 57% and it's a 97% relative humidity day, isn't that going to change over the course of the day? And the answer is no, because it takes a very long time, days, maybe even a couple of weeks, before the ball stabilizes to whatever environment that it's in.
So a lot of longtime baseball fans are, they track statistics over time. And of course, way back when Babe Ruth or Carl Yastrzemski or somebody else were playing, they weren't putting baseballs in humidors. They got the records that they got based on what they did in the playing conditions. Do you think Major League Baseball is over-managing these types of issues to make it in an effort, I guess, to make the game more consistent, or what is your opinion?
I actually think, and even recommended to Major League Baseball, that they do exactly what they're doing. One of the charms of the game of baseball is that every Major League stadium is different. And we like that. Fans like that. Mm-hmm. It's not like a football field or a basketball court, for which they're all identical. They're different, and that leads to differences in how the game is played. However, a lot of people think, and I guess I'm one of them, that the ball itself is sacred, that everyone should be playing with the same baseball. There, back 7 or 8 years ago, 9, 10 years ago, I guess, there was a very rapid increase in the number of home runs hit in Major League Baseball. And fans were speculating that Major League Baseball was purposely doctoring the ball, making the ball, this coefficient or restitution factor, bigger, so you get a bigger bounce, faster speed off the bat, and therefore longer distances, more home runs. That was eventually shown not to be the case. But there is this feeling that the ball shouldn't change. Other things could change. Ballparks change. The weather changes, and we can't do anything about that. But the baseball ought to be kept as constant as you can keep it.
And then one final question. We mentioned humidor, but what about humidity? Does humidity have an effect on home run trajectories?
Not very much. I mean, the effect of humidity on the air density, which is ultimately what matters, is really quite small. So you could have big swings in the relative humidity and have it barely affect the flight of the ball. It's commonly misunderstood. People think that high humidity means high air density, and in fact, it's just the opposite. But in any case, when I'm doing calculations, I don't even worry about what the humidity is. I just assume it's around 50 or 60 or 70%, and whatever it really is, it simply doesn't matter a great deal.
Yeah, and water vapor is only maybe 10 to 20 grams per kilogram of air.
Right.
So that's really not that much in terms of mass.
Right, exactly.
If you're just joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois Urbana-Champaign. I'm Steve Nesbitt, professor in the Department of Climate, Meteorology, and Atmospheric Sciences here at the U of I. Today we're talking about how weather affects baseball and how it's played with Alan Nathan, professor emeritus of physics at the University of Illinois Urbana-Champaign. So, home to the Chicago Cubs, Wrigley Field is the second oldest ballpark in Major League Baseball, and it's also known for its wind. Is there any lore about Wrigley Field and how it gets affected by the weather, maybe different than other stadiums?
Yeah, well, this thing that I mentioned earlier about weather-applied metrics, one of the things that's somewhat unique about Wrigley Field is that the height of the stands behind home plate is quite a bit shorter than in other stadiums, and that has a definite effect on the wind patterns within the ballpark itself. These people from Weather Applied Metrics have been quite quantitative about the effect that has. There have been twice this year there have been crazy fly balls at Wrigley Field. One where the wind was blowing out at some very high speed, and the ball traveled much further than anyone expected. And another where it was just the opposite. The wind was blowing in, which shortened considerably the flight of the ball. So a ball that probably would have traveled 400 feet probably traveled, 350 feet or maybe even a little less.
Yeah, and of course, Wrigley Field being on the north side of Chicago is affected by the Chicago lake breeze. Mm-hmm. So oftentimes during an afternoon game, the wind could be blowing in one direction and then all of a sudden shift to be off the lake, and the temperature could plummet quite a bit. So if you've been there, you often are good to bring a sweater, especially early in the season. But I'm sure the Cubs understand this, but I wonder if visiting teams understand this from that perspective.
All American League teams visit Wrigley one series every 2 years, so they're probably not used to it. The National League clubs are there more often. At least the ones in the Central Division are there maybe 3 times a year, 3 series a year. So you become accustomed to it, I guess.
Yeah, do Major League teams have weather analytics as part of their data that they look at?
Oh, absolutely. If there's data to be had, they're looking at it. They try to take everything into account. And they even try to adjust their strategy based on the current weather conditions.
So do you know what kinds of things they can adjust?
Look, for example, if the wind were blowing in, if I were advising them, I would advise them not to try to hit fly balls. Try to keep the ball low and hit line drives, which, you're not going to hit a home run, but you certainly could get on base quite often. So are they actually using that as part of their strategy? I actually don't know.
Yeah, it would be interesting to know if they make any personnel decisions or, change pitching strategies or other things based on that. If you're just joining us, this is Weather Realness, the podcast about weather and climate from Illinois Public Media and the University of Illinois Urbana-Champaign. I'm Steve Nesbitt, professor in the Department of Climate, Meteorology, and Atmospheric Sciences here at the U of I. Today we're talking about how weather affects baseball and how it's played with Alan Nathan, professor emeritus of physics at the University of Illinois Urbana-Champaign. So what's the most surprising thing you've ever learned from baseball studies?
The most surprising thing had nothing to do with the flight of the baseball. It had to do with the ball-bat collision. And it's this. When the bat beats the ball somewhere in the barrel of the bat, when the ball and bat are actually in contact with each other, whatever the batter is doing with his hands plays absolutely no role in what happens to the ball. The collision is so fast that nothing the batter could do while the bat and ball are in contact could possibly matter as to what happens to the ball. And it was a little surprising when I first learned it. And when, after having thought about it a little bit, it made from a physics point of view, it makes perfect sense.
So this is kind of like if the batter is maybe rolling the bat over or something, or?
Yeah, I mean, so here's what I like to tell people. The batter's job is to get the bat in the right place at the right time, and after which he could just as well let go of the bat prior to contact, and it doesn't make a bit of difference to what happens to the ball. And when I tell people that, they don't believe it, but it really is true.
That's interesting.
I mean, it seems like not very intuitive, but there's good physics reasons why that's the case.
Yeah, you're just trying to get that energy transfer, and I guess everything else is happenstance.
Yeah.
So you mentioned a bitter cold event at Comiskey Park. So what are some of the worst weather conditions you've ever experienced or watched on TV for baseball?
Oh, I've seen games where it's snowing. I think Detroit a few years ago in April. Obviously not fun to play in, not fun to watch either, particularly. The Comiskey Park game when it was extremely cold, And then maybe 10 years ago, I was at a game in Busch Stadium, and it was just the opposite. It was 90-degree temperature, but very, very high humidity. It just felt miserable.
And do you have a favorite team?
Yes, I do. The Boston Red Sox.
Oh, very good. Well, I think we'll wrap it up there. Alan, thank you for joining us.
Yeah, thanks for having me.
So we've been talking with Alan Nathan, Professor Emeritus of Physics at the University of Illinois Urbana-Champaign. I'm Steve Nesbitt, Professor in the Department of Climate Meteorology and Atmospheric Sciences at the U of I. Thank you for joining us on Weather Realness. Do you have a weather or climate question you want us to answer? Leave us a voicemail at 217-333-2141 or email weatherrealness@illinois.edu.